Everyone to another class at Atlantic International University. So my name is Abdulqader and I'm very happy to be back here again. So today's topic is very important. It's a topic that concerns a lot of people's lives, which is plant process safety. And today I'll be trying to be giving you an overview without getting too technical, but just to give you a rough idea of what goes on behind plant process safety. So without further ado, let's begin. So we'll begin with a quick introduction. Then we'll talk about how is plant process safety is being implemented. Then we'll talk about the key process safety studies that are useful to ensure proper safety in these plants. Then we'll talk about previous incidents, which are a very important part to learn how we have learned from them. And then we have a conclusion followed by a quick exercise to jog our memory. And finally, like usually, we'll have the Q&A session to attend to any questions that you may have. All right. So without further ado, let's begin an introduction. So let's start by defining process safety. So what is process safety? Well, process safety focuses on preventing hazardous release of chemicals, energy, or materials that could lead to significant incidents like explosions, fires, or toxic releases. It's about how to manage these risks in an industrial process. Now, there's something to note. Unlike occupational safety, which is a different thing, that occupational safety focuses on individual well-being, whereas process safety aims to protect systems and facilities. This is important in several industries like oil and gas, chemicals, pharmaceuticals, food processing. Basically, any process plant that exists, there needs to be proper process safety measurements in place. So, as I said, why does process safety matter? Well, of course, first and foremost, to protect lives. Process safety prevents catastrophic incidents, ensures the safety of workers and also the nearby communities. Imagine a scenario like a chemical plant explosion. Process safety can help to prevent such scenarios. Also to safeguard the environment, so this means reducing the risk of large-scale environmental disasters such as oil spills or toxic leaks, which can have devastating long-term effects. So not only the humans, but we should also care about our environment. Then also the economic implications. So accidents can lead to massive financial losses. So when we talk about the process plant, we talk about millions and even billions of dollars that could be lost from such disastrous incidents. So implementing process safety helps to mitigate these risks and also keeps the operations running smoothly. And finally, of course, the regulatory compliance. So businesses must adhere to strict process safety regulations to operate within the law. So failure to do so can result in penalties, shutdowns, or worse. So in short, process safety is not just about the rules, it's about lives, the planet, and sustainability for the business. So let's now explore how it can be implemented in the plants. But before that, as I said, we have a quick distinction between process safety and occupational safety. So process safety focuses on preventing large-scale incidents, whereas occupational safety focuses on preventing individual injuries. So for the scope of process safety, this includes the systems, equipment, and the processes, whereas for occupational safety, it includes the workplace conditions and the personal safety, like for example, on site. So, an example of process safety, as we said, could be explosion prevention, toxic release control, while for occupational safety it would be wearing the hard hats, the fall prevention, the PPE, which is the personal protective equipment. So the gloves, the boots, all of these equipment are considered PPE, which is under process occupational safety. As for the pillars of process safety, first we have process design. So we need to ensure that we create robust systems to handle hazardous materials effectively. A well-designed process minimizes risks right from the start, ensuring that safety is built into the operation. Then we have the risk management, where we focus on identifying, evaluating, and mitigating risks. By understanding potential hazards, we can proactively address them before they lead to incidents. Then we have safety culture. So safety culture is an important part as it ensures that the commitment to safety is embedded in our organization. It's not just about the rules and protocols. We don't wear gloves just because the law tells us to do so, but we do so to foster a mindset where safety becomes second nature for everyone. Just like, for example, tying your seatbelt. You don't do it just so you don't get stopped by the police, but you do it for your own safety. And lastly, we have the emergency preparedness, which despite our best efforts, incidents can still occur. At the end of the day, we need to have plans in place to respond effectively if something happens. So this ensures that even in the face of an emergency, we can minimize the harm to people, the environment, and the facility. So all of these pillars work together to create a comprehensive approach to process safety, highlighting the importance of planning, culture, and preparedness in keeping industrial operations safe. So let's now dive more into the implementation of process safety. So what does implementation involve? Well, first, it involves establishing frameworks, practices, and systems that are specifically designed to handle hazardous materials safely. So this includes defining clear protocols and ensuring the availability of safety systems. Second, process safety must be integrated into every stage of plant operations. This includes the design phase, daily operations, and even during decommissioning. This integration ensures that safety isn't just an afterthought, but a fundamental part of a plant's life cycle. So a good example of this is a chemical plant implementing emergency shutdown systems that can prevent, let's say, a reactor overpressure. So these systems act as a safeguard, automatically intervening to avoid incidents when pressure thresholds are exceeded. So let's say my maximum pressure is 10 bar. Anything greater than 10 bar, maybe my vessel cannot handle and it will explode. So when I see that my pressure increases more than 10 bar, I will add a system, for example, it's called a rupture disc or a device that would release the pressure somewhere else. So either through to a safety like usually not to the environment, but as a worst case scenario, if our vessel is not including a very toxic material, we could also, you know, release it to the environment so that the pressure overpressure can be avoided. So that is very important, and it depends from process to process, of course, and depending on also how your vessel is designed. So the key steps in implementing process safety. First is the process hazard analysis. So these steps involve identifying potential risks in processes and evaluating their consequences. So before we know how we should protect our system, we need to know what is the problem, what are the potential risks. For example, a refinery conducts a PHA to evaluate the risks in a distillation unit, or the distillation unit is the unit, for example, which helps us to purify our oil. So it's important to know, okay, what could happen in this distillation column? How can it fail? What are the potential explosion scenarios, and so on. Then it's the management of change. Management of change, believe it or not, is really, really important. And most of the time, it's what leads to failure of our equipment. Because when a modification that is done to an equipment, we also need to update how we protect this equipment. Because let's say that this design vessel is designed for 10 bar, but then 10 years later, another engineer comes and says, okay, no, I would like to operate at greater than 10 bar. And then we see that we haven't updated our vessel itself, and this can lead to a potential explosion or a potential safety issue. So it's very important to update. So, example, I've written here the updating a storage tank material to handle corrosive chemicals safely. So the management of change, or MOC for short, is a very important procedure and usually takes a lot of months and years to update. So it's important to do it step by step, you know. And lastly, we have the operation discipline. So there needs to be discipline where everyone will apply the safety protocols in a day-to-day operation. So it's about creating a culture where everyone follows the guidelines for their own safety. So this is very important. So example of this would be to ensure that you do routine inspections of valves and pipelines. So for example, a valve might last for a long time, but let's say after a few years, there's some leakage issues. So there needs to be a routine inspection to ensure that all the equipment are operating in a safe manner. Moving on, we have the building blocks of process safety. So we have the engineering controls. So this involves designing and implementing equipment to minimize risks directly. So it's about creating systems that are inherently safe to operate. For example, as I said, we can install a pressure relief valve to prevent overpressurization and potential explosion on reactors. Then we have the administrative controls, which are the policies, procedures, training programs, and also the proper management of risk. So, for example, an example of that would be developing a clear evacuation procedure for emergencies to ensure that workers know how to respond swiftly and effectively. And lastly, there's also personal protective equipment. Although we say that this is for occupational safety, it is also in process safety where it acts as the last line of defense, safeguarding the individuals from the hazards that cannot be eliminated through the engineering or the administrative controls. So this is important to know. All right, now let's talk about process safety tools and techniques. So as we said, we have engineering solutions that we mentioned. We can add a double-walled storage tank, for example, to ensure that there are no leaks. We can also use risk assessment models. So these models will help us to identify and evaluate and control risk in plant operations. So, for example, we use risk matrices to prioritize the corrective action. So what is a risk matrix in short? Let's say that explosion is from the risk matrix is a very, very dangerous scenario. So it might be colored red. So when we look at the risk matrix, we ensure, okay, this is red. We need to reduce the risk to maybe a green level. So usually the risk matrix is green, orange, and red. So green is say like least dangerous, and red is most dangerous. So these type of risk assessment models can help us to know, okay, which scenario I need to tackle, and which is the most important or the most dangerous risk that I need to mitigate. And then we have the incident investigations. So learning from the past incidents is very important to improve safety protocols. So analyzing the root causes of a gas leak to prevent reoccurrence. So because the way the plant works is very hard to explain with science, even though let's say you're an engineer and you've studied with PhDs and so on, how it works in the industry is very, very difficult to know. So a way to predict or a way to learn is to learn from our previous mistakes. Okay, what happened there? What we can do next time, and so on. So this is very important to learn from past incidents to improve the safety protocols. Then we have the maintenance and reliability is, of course, every now and then we need to check everything is working well. There's no issues, so we can prevent any disasters from happening. And lastly, the emergency response planning. So let's say that if something happened, what can we do? So we have to prepare for unexpected events with a clear and actionable plan. So where do we evacuate? How do we proceed? These are all very important things to take note of. Now let's talk about the role of technology implementation, because now we are in the age of technology, of the age of the internet, and of course this helps us to also be operating in a safer manner. So we can use digital tools like real-time monitoring and data analysis using the Internet of Things devices. So for example, sensors tracking the pressure and pipelines, and if there's something, it alerts the operator. Okay, there's an alarm that there's a pressure increase in this area and you need to do something, for example. Then we also have automation. So now most of plants right now run with automated control systems. So this can reduce human error with advanced automation and control systems. So for example, if an issue happens, an operator doesn't need to intervene and close the systems. We will have automated shutdown systems that can close the plant, for example. And then lastly, we have the data-driven insights, which is using the historical data, we improve safety measures and risk assessments. So this is very important. So we use past incident data to redesign, for example, a storage tank. So these are all important. We see that technology can help to improve our process safety. Then we have also the workforce involvement in process safety. So we need to ensure training and competency. So regular training to ensure that staff understand the process safety principles and their roles. So not everyone on site will understand how a process works, but it is important to tell everyone, okay, perhaps when the operation is happening, do not go close to this equipment, for example. So it's important to also simulate different drills, like fire drills. Let's say there's an emergency scenario. Where do we proceed? Where do we move? This is important. Then also the safety culture. So encouraging open communication about safety concerns. So let's say we create a suggestion box so that workers can report unsafe conditions anonymously. So because sometimes, in work, the operator might be he's scared from his boss and he might see something that's off, but he wouldn't speak about it. So we need to ensure that we have systems in place that can accommodate anonymous reports so that everyone can report any unsafe issue, comfortably without fear of losing their job and so on. And lastly, as we said, the incident reporting. So we need to ensure transparent and non-punitive system for reporting near misses or hazards. So we need to track and investigate near misses in for example, in a fertilizing manufacturing unit, just to give you an example. All right. Now let's talk about the key process safety studies. So how do we track process safety usually in a plant? So we have a lot of studies, and I'll just talk about the most famous ones, I would say. So we have first hazard identification, which is HAZARD for short. Then we have hazard and operability study, which is HAZOP. Then we have the layer of protection analysis, also known as the LOPA. Then we have the failure modes and effects analysis, also known as the FMEA. And then we have the QRA, which is the qualitative risk assessment. So let's take a look at HAZARD first. So what is HAZARD? So HAZARD is a proactive study designed to uncover risks that could impact people, the environment, or assets. It focuses on identifying these risks early, even before detailed studies begin. So the scope of a hazard, it covers all phases of the plant life cycle: design, operation, and even decommissioning. Unlike more specific studies, it takes a broad view, addressing risks that aren't solely process related. For instance, it considers risks from extreme weather conditions, such as high winds that could destabilize the outdoor storage tanks, for example, or flooding that might disrupt operations. So why is hazard important? It's because by providing a high-level understanding of potential hazards, hazard lays the groundwork for more detailed and targeted studies like the HAZOP or the LOPA, which we'll be talking about shortly. It's basically the first step in ensuring that no risks are overlooked. So in hazard, we ensure that we identify all the risks that are general to the process plant. Then we have the hazard and operability study, HAZOP, which is a very, very important study, and every process plant more or less would need to do this HAZOP study. So it's a structured approach to identify deviations in processes and assess their consequences. Essentially, it helps answer the question, what could go wrong? What could go wrong during the normal operation? So how does it work? A HAZOP basically uses a set of guide words like no, more, or less to systematically examine potential deviations in a process. For example, what happens if there is no flow, more pressure, or less temperature? These deviations are then analyzed for their impact on the safety, the environment, and operations. So, an example of this: imagine a reactor feed line experiences a blockage. The potential consequences could include overheating and overpressure. So safeguards like alarms might already be in place, but the recommendation could be to install automated shutdown systems to prevent the escalation, for example. So this is very important to know how, basically in HAZOPs, we study different scenarios, different deviations, and how we can mitigate those different dangerous scenarios. So in summary, HAZOP is basically like the detective for process safety. It identifies where things might go wrong and it recommends how to prevent or mitigate those risks. Then we have the layer of protection analysis, which is the LOPA. So this is a key methodology in risk management. So what is a LOPA? A LOPA is a method used to analyze and reduce risks in industrial processes. It focuses on identifying multiple layers of protection that can prevent accidents or reduce their impact if they occur. So how it works is the process begins by identifying potential risks, such as equipment overheating. Then protective layers are evaluated, which could include alarms, safety valves, or an emergency shutdown system. Lastly, the safety integrity level, which is the SIL, is determined. This step ensures that the protective measures are robust enough to handle the identified risks. For instance, SIL allocation defines how reliable a safety system must be, and SIL verification ensures that the chosen protection meets this reliability. So if a scenario, for example, needs a valve of a certain type of a SIL 2, for example, then it needs to be that level so that we ensure that we can protect our system. So this is important to know our systems in the plant. So for example, imagine a critical valve controlling pressure in a system. So LOPA would evaluate whether an automated shutdown system is sufficient to handle the risk, and if not, it would recommend adding more safeguards to meet the safety standard. So in short, LOPA is very important because it ensures that safety measures are strong enough to prevent major accidents and also helps industries make smarter decisions about adding or improving protections. So LOPA is like building a multi-layered defense system to minimize the chance of any single point of failure leading to an incident. Then we have the failure modes and effective analysis, which is the FME. So FME is a systematic study to identify how equipment might fail and the effects of those failures. So this one focuses on single point failures and their consequences. So how it works is it breaks the systems into components, let's say valves, sensors, and so on. Then it identifies a potential failure modes for each system. Let's say the valve is stuck, for example, that's a failure mode. Then it analyzes the effects of each failure on system performance and safety. So let's take an example. Let's say failure mode. Gauge fails to detect overpressure in a pipeline. The effect is a risk of equipment damage or explosion. The mitigation is install redundant pressure gauges and safety relief valves. So if we have one only and that one could fail, then we need to install separate ones that can help us to avoid this issue. So FEMA is important because it helps improve the reliability by addressing potential weaknesses, and it also enhances preventive maintenance strategies. Lastly, we have the QRA, which is a quantitative risk assessment. So it's a comprehensive study that provides numerical estimates of the risk levels. It evaluates the likelihood and severity of potential incidents. So how it works is that it identifies hazardous scenarios, so let's say a chemical leak, for example. Then it assigns a probability to events using historical data. So this is more quantitative, hence the QRA name. And it also quantifies the consequences such as fatalities, financial losses, or environmental damage. So how many people could be, damaged, or how many fatalities could result from the scenario? What is the money that we might lose, and so on. So let's take a chemical spill near a resident area. The scenario is that a pipeline ruptures, releases toxic gas. The probability is 1 in 1,000 years based on historical data. And the consequence is it impacts the radius, potential casualties, and evacuation requirements. So QRA is important as it helps prioritize the risks based on their magnitude, and it also provides a basis for resource allocation and emergency planning. So with that said, now let's talk about this previous incidents. So I told you a lot of studies. Even though we have a lot of studies, there are unfortunately a lot of incidents that happened. The first one, which is one of the most infamous industrial disasters in history, which is the Bhopal gas tragedy of 1984 in India. So what happened? Basically, a pesticide plant in Bhopal, India released 40 tons of methyl isocyanate gas due to a storage tank failure, which is a toxic gas. What happened is that over 500,000 people were exposed to this gas, with thousands of deaths and long-term health effects. It's considered the world's worst industrial disaster. And even now, we have parents and grandchildren to this day who are still being affected from this tragedy. So what we can learn from this is that the importance of safety systems to detect and mitigate toxic releases. So we need to ensure that we need to detect if there's any leakage, if there's any issue with our tanks, and there's also the need for emergency response planning and community awareness. The next one is the deepwater horizontal oil spill, which happened in 2010. So what happens, an explosion on deepwater horizontal drilling rig in the Gulf of Mexico caused the largest marine oil spill in history. The impact was that 11 workers unfortunately lost their lives, and over 4 million barrels of oil spilled into the ocean and devastating the marine life and ecosystems. So not only do we affect the environment, but we also affect the sea and the animals and the ecosystems that are in the sea. So the key lessons are there's a critical importance of blowout preventers and other safeguards, and also the need for strict maintenance and safety checks, because the issue was that there was a safe there was a let's say there was some equipment that were not checked properly, and this is what led actually to this problem. Then we have the Texas City refinery explosion, which happened in Texas in 2005. So what happened is a hydrocarbon vapor cloud ignited during startup operations at a BP refinery in United States, Texas. The impact was 15 workers were killed and over 170 were injured. Severe damage happened to the refinery and nearby areas. The key lessons is that there's importance of operation discipline and adherence to startup procedures. So yeah, this brings me to the conclusion of this talk, which is process safety is very important. Process safety is the foundation of safe, sustainable industrial operations, protecting lives, the environment, and assets. So it must be integrated in every stage of plant operations. Incidents like the Bhopal, Deepwater Horizon, and Texas City show the devastating consequences of inadequate safety measures. So these events highlight the importance of learning from failures to build safer systems. We also see that technology helps us to prevent dangerous scenarios. And lastly, despite technological advancements, human error remains a significant factor in industrial disasters. Building a strong safety culture, providing regular training, and fostering awareness is very important to ensure we minimize the human mistakes. And lastly, process safety isn't static. It requires constant evaluation, adaptation, and innovation to meet new challenges and ensure a safer future.